Assalamu alaikum wa rahmatullahi wa barakatuh. Today we're going to discuss a new topic for AB statistics, the distribution associated with a difference of sample mean. As usual, we have to know the conditions when I'm going to use it. First, as usual, also simple random sample. Two, it should be independent samples, so they don't rely on each other. Number three, sample size n more than or equal 30. Okay, so if we have that, we have some facts that are true. First one, the difference between the average is good estimator of the expected value. Number two, the standard deviation in that case will come from the formula square root for variance 1 divided by n1 plus variance 2 divided by n2. I'm going to take the square root. Number three, if the two population are normal, so the difference between the average is normal. For the t-test, we have it observed minus expected divided by standard error. In another way, with the symbol, it's x average 1 minus average 2 minus mu1 minus mu2 divided by square root for standard 1 square, or the variance square, divided by n1 plus variance 2 divided by n2. That's how to calculate the t-value. What about the degree of freedom? The degree of freedom in that case is going to come by the variance 1 is divided by n1 plus the variance 2 divided by n2 square divided by 1 over n1 minus 1 multiplying by variance 1 square divided by n1 whole square plus 1 over n2 minus 1 multiplying by variance 2 square divided by n2 whole square. So can we have an example? Yes. So note that the solution will be shown for both calculation of the degree of freedom for the t-statistics. It has been accepted for many years that academic performance of men in technical fields who study on average exceeded the performance of women in the same field. A random sample of 40 men, so N1 is 40. That's the men. And 50 women from a large university selected, with a mean for men 3.065 and for women for 2.195, and standard deviation for men 0.251 and for women for 0.341. Find the probability that the mean GPA found in a sample of the size will yield the difference, so male minus female, of mean of 0.870 or less. In the accepted difference, so that's mu1 minus mu2 of 1. Now the first step we have to check. First, they come from simple random sample. Yes, it's stated. Independent sample, we have male and female, so it's independent sample. The population is more than 30, yes, for men and women. So now we can start doing the calculation. So for T, we said average 1 minus average 2 minus mu1 minus mu2 divided by square root 4 standard deviation square n1 plus standard deviation 2 square n2. So I'm going to start to plug in. So the average for the men was 3.065 minus 2.195, and the accepted one is 1 over the square root 4 3.065 square divided by 40 plus no, the standard deviation, sorry. The standard deviation for the man is 0.251 square over 40 plus 0.341 square over 50. So it comes with the T is negative 2.081. Now what about the degree of freedom? So I plug in the formula, S1 square over N1 all square plus S2 square over N2 all square divided by 1 over N1 minus 1 multiplying by S1 over N1 all square plus 1 over N2 minus 1 multiplying by S2 square over N2 all square. I'm going to start to plug in, so 0.251 over 40 plus 0.341 square over 50 all square divided by 1 over 40 minus 1 multiplying by 0.21521 square over 40 all square plus 1 over 50 minus 1 multiplying by 0.341 square over 50 all square. So when you do the calculation, so the degree of freedom is going to be 87.45. Now to find the value, so I'm going to use TCDF and the lower value because I want less, so negative 1 e to power 99, comma, the upper value is negative 2.081, comma, and with a degree of freedom 87.45, and I press enter, it's going to come up by 0.0202. That's it. Wish you understood. Have a good day. Assalamu alaikum warahmatullahi wabarakatuh.